the concept of data interchangeability, so data should be interchangeable. Simply monitoring requests, so proxying and watching data flow by, and just simply dumping it to a file is not really helping the situation. That's what pretty much everybody is doing right now. And that's how we're, as an industry, kind of contextualizing data right now. If you don't have the context for what it is that you're mapping, it's not going to help, right? Randomly collecting data for parameters and then shoving them back into the parameters later without knowing why they were there in the first place doesn't help. Because some of the time you need new data, some of the time you can't reuse, and some of the time, it fits. How do you tell the difference? And data can be direct or indirect too, but I'm not going to go into that because that gets ugly. And more importantly, we're not specifically defined within an action or at that edge. The data values are assumed to be arbitrary. So if you're not defining data specifically for a parameter or a point, then it can be whatever you want. So then we can't address it the way we address it today. Just dump anything into it, right? ABC123, Jack Frost, whatever you want to put into that parameter is fine with us, as long as it's not needed. And I'm kind of a visual learner, so I think of things this way. If I want to retrieve something from a safe, how would I do that? Okay, well, first I'd map it for myself, I'd add some data, and then I'd execute, right? So I need something from a safe, so I'm going to go get it from the safe. So what do I need? Well, odds are you need a combination or a key. So since it's a combination safe, I need the combination. In today's general application testing, I would just throw random numbers at that, maybe letters, maybe variations of strange characters, and hope that the safe opened eventually. Odds are, if there's something in that safe that I needed, I might not ever actually get inside that safe. That's rather unfortunate. But if I have the right combination at on the bottom there, and I map it to that flow, I can now open the safe. So I don't have to beat on it with the sledgehammer until it breaks, because it may never actually break. Make sense? Like I said, I'm kind of a visual learner, so I do pictures, and I hope you guys benefit from these as well. So more examples. I like website registrations because they always produce such interesting examples of, especially when you throw captchas and stuff in the mix. But if you've got the landing page, inevitably you hit a fork. Do you log in or do you register? Well, there's two flows right there, right? One goes into a login, go do some stuff. The other one goes into a registration flow. In the registration flow, you have to have stuff to register with. You can't just throw garbage data in the form. Why? Because for some really weird reason that I haven't really had anybody fully explain to me yet, they always ask for your email address twice. Maybe because they really want to be sure you have your email address right. And the form fields generally aren't labeled email address again, right? It's email address 2 or something. So what do most pieces of security testing automation do? Email address, jsmith@someplace.com. Ooh, email address 2. Let's throw something else in there, jsmith@someplace2.com. Guess what? Those two don't match. Fail. And what are you going to do? You're going to cycle through that registration page a billion times. You're never actually going to get to this page here, where there's a nice, juicy user, SQL injection vulnerability. We can extract the entire database and forget about the whole login page because you already own the app. How do you fix that? Well, you tell the app, tell your testing tool that, hey, by the way, these two params have to be the same. Here's what they are. Here's what they are the first time, the second time, the third time, the 15th time. Heck, write tell it that, jsmith1 through 100 at AOL.com. I feel sorry for somebody who has that, but, whatever, right? You come up with some kind of variation and mutation of that logic. So putting this all together and actually making this make some kind of sense, if we look at it at a functional and a technical level, at the functional level, we're just drawing boxes. We're just going to map this out. We're going to pretend we have a really big whiteboard. And if you do application testing, as anything more than a hobby, you probably have a whiteboard or at least access to Visio. And so we're going to draw this out at the functional level to help you kind of in your head understand how the application functions, how it flows, maybe what it even does. You know, in my past life, I used to test web applications for an energy services company for a while. And we used to get apps all the time that we just get a URL and some credentials to. Well, one time we found some really, really big vulnerabilities, and you know, you just classify everything the same. So vulns are vulns, big deal, right? Except when vulns are attached to a power gen facility that just happens to have a nuclear reactor attached to it. Well, without actually knowing the context or what that app does, i.e. monitor, works on the system or connects to the monitoring, the web app that monitors a system, that monitors cooling rod temperatures and such. And if you can kind of mess with that, you know, bad things tend to happen. Small hole in the ground becomes a big hole in the ground. Tough audience. What is a nuclear power reactor right around here I don't know about? Cool. So we go down into the technical level, and then we map these technical things from an EFD into like from a JS DOM to an HTTP state, right? And then go from that, we map data onto it, and then you throw all this stuff together. And I don't know what this is going to look like ultimately when we're done with it. We're still working on that. So the applications of this stuff, and there's a couple really big ones, so in 5 minutes I'm going to attempt to make this really fast. So flow-based threat analysis, because we know how applications function, we know what flows do what, we can tell which pieces of the application are more important. Therefore, we can contextualize vulnerabilities. Therefore, we can score them differently. SQL injection here may not be the same as SQL injection there. Detect dangerous information flows within the application. This is a big deal because we can't really do this today easily. Coverage analysis, I love. This is like my favorite thing to talk about because flows defined by functional specification can be compared to security testing to determine gaps. I can look at the functional spec, I can look at what the flows that we tested from the application, I can say, hey, look, we missed a major chunk of the application. Hey, why did we miss a major chunk of the application? Oh, that's right, we didn't have the correct data. Now we can test the rest of it. Flow-based reproduction. Okay, has anybody ever handed a vulnerability report to a developer only to have them say, I can't reproduce this, this must be garbage? Yeah? What if you could just write some nice squares, boxes, and circles for them, and then just easily show them how to reproduce this? Right? It makes things easier when you can show them exactly how to reproduce a defect within the context of their data, their application, their code. It just, the mentality clicks. You get like that mental light bulb that goes on over their head. It's really weird. You get that, defensive look, like, this is crap, I don't believe this, to, I'll be right back, I'm just going to fix that real quick. And it's not that developers are purposely writing source code, bad source. I don't believe that either. It's that they just don't know better. It's not part of their job description. It's never going to be. That's fine. What we have to do is enable them to make it absolutely simple or effortless or make security invisible and make them believe that it's actually a big deal. You can use up my 5 minutes, Jim. Go ahead.
Would you consider taking that one step further? I had a couple pen testers giving me actual unit tests instead of just a diagram, actual code that I can use to reproduce. Dennis and I were talking about that. I'd like to take that concept one step further.
Brilliant.
The pen tester shows up and they leave. I want all their intellectual property, a batch of unit tests.
Brilliant. Yes, but taking this one step further, what Jim is saying, taking this one step further and going from boxes to actual source code, taking the source they used, the data they used, mapped against this, that you can just simply use to demonstrate exactly what was done. Absolutely, brilliant. It's an educational tool that can be used and reused over and over and over again. Yes, I love that. So this is another interesting point here. This is a dysfunctional use of this concept of EFD, because I would argue that we don't have a way of testing business logic, security testing business logic, and we're probably not going to in any meaningful way anytime soon, except if we can teach our automation what the correct business flow of the application is, right? Box 1, 2, 3, 4, 5, 6, 7, 8, and then let the tools try to skip boxes, skip process. So 1, 2, 3, 4, 5, 6, 7, 8 can be hit the login page, log in, go to a shopping cart, or search a catalog, go to a shopping cart, add the cart, check out, check status, log out. Can I go from log in to check status? Maybe that's not something you're supposed to be able to do. Or can I just go straight to can I go straight to check out? That sounds like a CSRF vulnerability, doesn't it? What if we could do this? The what ifs become, yes, we can. Start to sound like the president. Trust me, it's not on purpose. Being able to actually map the applications produces a wealth of intelligence that security has never cared to have, that's been sitting at our fingertips, and it's in a group called QA that we just never talk to. And it's mind-blowing that we haven't. So I'm taking all this kind of intelligence that I've gotten from these guys, and the next generation of automation, and this is kind of where this gets a little philosophical if you'll work with me for a second. The next generation of automation is really automating the automation of execution flows, being able to say and build maps of user-driven functional scripts, being able to look at a functional specification and build a script that can be tested. Forget security tested, tested period. Functional tested, performance tested, security tested, just tested. Why does security have to be such a special thing that it's done by a special group called security? It shouldn't be our problem. Because we don't scale. There's usually one of us or two of us in a large organization to 1,500 apps to 1,000 QA people. I know I'm not wrong. I've met these people. So the record and playback, right? Record HTTP requests, JavaScript events, and client UI events. We're not doing this today. Not any meaningful way. A lot of the stuff that's happening on the user UI end, we're simply ignoring. What if web vulns exist on the UI? Wait, what if? No, they do exist on the user UI. And attacking is replaying these flows rather than just replaying what we proxied in a browser state. And auditing HTTP parameters and HTML inputs, right? All this stuff together. And we can do things like automatic exploration. Being able to explore adjacent paths of an application by finding things in logic that we see here. Like we map one piece of application logic in one way and then let the tool or the tools or the automation find other adjacent pieces of logic that mirror what we've already done using similar sets of data. And so for next time, because I've run out of time, is layered automation infused testing. What the hell does that mean? And concrete metrics and KPIs, and stick around because there's a lot of good stuff coming there. And I really don't have a cheesy cliche, but I just say let's get to it because there's a lot of work to be done. And please stop point and click testing because it's not making this industry any better and it's actually probably hurting. So yeah, intelligent automation. Woohoo!